linear functional. Let V be a vector space over the field F. Pi be a function from the vector space V to the field F is called linear functional. F for each two vector uv of the vector space V and alpha beta be any two scalar. Pi alpha u plus beta V is equal to alpha phi u plus beta pi V. In other words, a linear function on the vector space V is a linear transformation from the vector space V to the field F. For example, the set V over the field F, that is the vector space V over the field F, consists of the elements of this vector space is in the form of is an n tuple of elements of this vector such that a1 a2 up to an are the component of this vector. For each a1 a2 up to an are the element of the field. Pi I be a mapping defined from the vector space V to the field F such that pi I a1 a2 up to an is equal to ai. That is, when we apply the function phi I on any vector of the vector space V over the field F, which gives the ith component of this vector, then phi is a linear function on the vector space V, because when we select two vectors, these two vectors from the vector space V and alpha beta are any two scalar, and apply pi I on the sum of the product of this vector, which is equal to the simplest form of this vector. This vector is alpha a1 plus beta b1 is the first component of the resultant vector, and alpha a2 plus beta b2 is the second component obtained from the simplification of this process of this vector, and so on. And the last, that is the nth component of this resultant vector obtained from the simplification of these this process is alpha an plus beta bn. And when we apply phi I on this resultant vector, which gives the ith component of this vector, which is equal to alpha ai plus beta bi. And the ith component of the ith component ai is also obtained from the vector a1 a2 up to an when we apply the function phi I on this vector. Therefore, ai is also equal to pi I a1 a2 up to an, and bi, this is the ith component of this vector, which also we can obtain when we apply the function pi I on the vector whose components are b1 b2 up to bn, which gives the ith component of this vector. That is the function phi I, or the mapping pi I, satisfy the condition of the linear transformation from the vector space V to the field F, and is obviously called a linear function on the vector space V.